when engineers from the Fedorenko 38th Armored Tank Technical Research Institute of the Russian Ministry of Defense pried open the U.S. made M2A2 Bradley infantry fighting vehicle captured on the Ukrainian battlefield. What lay hidden beneath the cold steel hull was not only the cutting-edge technology of the U.S. defense industry, but also a shockwave that upended Russian military perceptions. The disassembly report published in April 2025 revealed near brutal data. This 32.7-ton steel behemoth's front-mounted basic armor was capable of withstanding the Russian military's most advanced 30mm 3UB or 8 fin stabilized discarding sabot armor-piercing rounds. When equipped with Bradley-2 reactive armor, its equivalent protection approached 500mm of homogeneous steel, rendering even PG-7VL anti-tank rockets ineffective. What shocked the Russians even more was its V-shaped bottom design, 3 layers of aluminum steel plates sandwiched between Kevlar ceramic composite anti-mine layers, combined with hydraulic shock-absorbing seats, reducing the blast wave from a mine explosion by 70%. In contrast, the Russian BMP-3, which the Russians pride themselves on, had its single-layer bottom plate torn apart like paper in the same test, with crew survival rates less than a third of those of American tanks. The disparity in firepower systems is equally striking. The M2A2 25mm chain gun fires depleted uranium armor-piercing rounds at a rate of 200 rounds per minute, penetrating 66mm armor at a kilometer distance with ease. The BGM-71F anti-tank missile, with its 800mm penetration depth and top attack mode, turns the turret top of the T-90M tank into a death trap. In contrast, the Russian BMP-3's 2A7 230mm cannon has only half the accuracy, and its outdated optical fire control system results in a staggering 3.5 mils dispersion range when firing its 100mm main gun while moving off-road. Interestingly, while Russian engineers painstakingly compared the M2A2 and BMP-3 in their reports, the Chinese ZBD-04 repeatedly appeared like a ghost. This 25-ton infantry fighting vehicle has never appeared on the Ukrainian battlefield. Yet it has sparked heated debate due to its perfect alignment with Russia's dream list. While its ceramic-based composite armor modules offer slightly inferior frontal equivalent protection compared to the M2A2, its innovative honeycomb-style compartmentalized protection design successfully withstood direct hits from 3UB or 6 armor-piercing rounds on the vehicle's sides. What truly piques Russian envy is its forward power compartment, plus rear ramp door layout. Full crew evacuation takes just 15 seconds, 5 seconds faster than the M2A2 and 28 seconds faster than the BMP-3. In terms of firepower configuration, the ZBD-04 demonstrates the subtle balance of Eastern ingenuity. The 100mm low-pressure rifled gun can fire high explosive rounds to clear fortifications and launch guided missiles to strike the top armor of tanks. At 4,000 meters, the 30mm chain gun's tungsten core armor-piercing rounds achieve over 100mm penetration at 1,000 meters, far surpassing the Russian round's weak 40mm penetration. The digital fire control system achieves a lightning-fast detect-lock fire response time of 1.5 seconds, 0.8 seconds faster than the M2A2. The Russian defense industry urgently prescribed a solution at the end of the report: upgrade the BMP-3M, install Dagger reactive armor, replace with a 57mm rapid-fire cannon, integrate short anti-tank missiles. However, reality froze all such fantasies like a Siberian cold front. Data from the Kursk Oblast test site showed that when the BMP-3M's weight increased to 30 tons, the 500 horsepower UTD-29 engine struggled in the mud, with off-road speeds plummeting from 45 km per hour to 27 km per hour. Even more brutal is the cost. Each BMP-3M now costs $3.5 million, 30% more than the base model, while 37% of frontline infantry fighting vehicles are still the Vietnam War-era BMP-1. The T-15 heavy infantry fighting vehicle project, which aimed to leapfrog ahead, has stalled due to Western embargoes on thermal imaging camera components and the inability to obtain Chinese alternatives. Russia's domestically developed OWL night vision system has a resolution that is less than 60% of the ZBD-04 is in real-world testing, turning nighttime battlefields into one-way slaughterhouses. This divide is vividly illustrated on the Ukrainian battlefield. Russian forces seized an M2A2 tank that was too heavy to be dragged out of the mud, ultimately becoming a static exhibit in Moscow's Victory Park. Meanwhile, thousands of miles away in Syria, a Chinese peacekeeping unit's ZBD-04 was hit by an anti-tank missile on its side armor, but the maintenance crew replaced the modular armor plates in just 15 minutes and returned to the battlefield. The despairing conclusion in the Russian report sums up the bitter reality: achieving both heavy protection and strong mobility on a 30-ton platform requires overcoming 3 insurmountable barriers: power, electronics, and cost. When re-examining the ZBD-04A, its 25-ton weight is like a delicate balance. Ceramic armor is 43% lighter than homogeneous steel yet provides equivalent protection. The all-electric drive system is 1.2 tons lighter than hydraulic transmission, and even the seats use carbon fiber frames to reduce weight by 30 kilograms. Behind these details lies China's military industry's pursuit of perfection down to the last gram. The M2A2 32.7-ton steel frame is a physical manifestation of American strategic doctrine. Designed for the Middle Eastern desert, this land aircraft carrier is heavily armored, with chassis bolts capable of withstanding direct hits from 12.7 mm armor-piercing rounds, yet it struggles to move in the spring floodplains of the Dnieper River. In the Pentagon's battlefield simulations, amphibious capabilities have never been a mandatory requirement. Powerful transport aircraft fleets and pre-positioned naval forces are the backbone of U.S. military cross-ocean deployment. Meanwhile, every gram of the ZBD-04's weight speaks to a different strategic logic. When amphibious landing ships open their hatches, the 25-ton displacement of the Type 726 hovercraft allows it to carry one additional armored vehicle. At 20 km per hour during beach assault, it reduces Taiwanese counter-landing firepower windows by 70%. Even the 3.2-meter wide chassis is precisely tailored to the standard dimensions of Chinese railway flatbed cars. This systematic integration from national strategy down to the smallest component contrasts sharply with the Russian military's disassembly of the M2A2. They discovered that the Bradley's fire control system required separate power supply, while the ZBD-04's electro-optical equipment is already integrated into the vehicle's intelligent power grid. The battlefield in Russia-Ukraine has written a new law for infantry fighting vehicles in blood. On a battlefield dominated by drones and smart munitions, survival no longer depends on armor thickness. The BMP-3M was destroyed by Lancet drones at a rate of 40% on the Donetsk plain, while the ZBD-04's GL-5 active defense system achieved an intercept rate of over 85% against rocket-propelled grenades. A more profound revolution has occurred in the information dimension. M2A2 crew members rely on voice radios to transmit target information, with an average time from detection to firing of 8 seconds. The ZBD-04's digital terminals directly receive drone footage, and the fire control computer automatically calculates firing parameters, completing the entire process in just 2.3 seconds. This generational gap manifested as a terrifying disparity during the Kharkiv counteroffensive. Ukrainian units equipped with Western information systems had daily intelligence updates that were 8 times those of Russian units. When Russian engineers finally closed the armor hatch of the M2A2, what truly shocked them was not the depleted uranium armor or the top attack missiles, but the philosophical revolution behind Chinese-made equipment, trading lightweight design for strategic mobility, using electronic information capabilities to compensate for physical protection, and achieving scale dominance through cost control. At the Omsk tank plant, workers are welding additional steel cage armor onto the BMP-3M chassis. These wartime emergency weight additions push the vehicle's total weight beyond 28 tons, drastically reducing the engine's lifespan to 800 hours. Meanwhile, at a Chinese test site, a prototype of the next-generation amphibious infantry fighting vehicle is undergoing sea trials. Its water jet propulsion system boosts its speed to 30 km per hour, and its roof-mounted laser countermeasure system can blind anti-tank missiles from 10 kilometers away. These parallel scenes highlight the ultimate competition in army equipment. While Russia continues to struggle along the traditional path of steel-based warfare, China has quietly developed a new breed of silicon-based brain plus steel body. As noted in an internal memo from the Kremlin, we do not need to replicate Eastern tanks, but we must understand their wisdom in using systems to resolve weight constraints.